Hello everyone. Jill and I welcome you to the online version of our session, Administering Your Enterprise Geodatabase Using Python. We both are product engineers in the Geodatabase development team at Esri. Jill is the Python GP go-to person in our team, and during this session, as she demos, you will find out why. Jill will be doing all the demos with Pro 2.5 that is now available to you. All the scripts that are demoed will work with both desktop and Pro with slight modifications. As we prepared for this presentation, we made some assumptions. You have basic knowledge of Python, or maybe you're looking to learn a little more about how it can be used. You know what a geodatabase is and have some knowledge of enterprise geodatabase workflows. You're here for the slides and the demo. This will be shared via a link at the end of this session. We will talk about the types of administrative roles which in many organizations are performed by separate individuals, while in some it is all rolled into one person's job. The create enterprise geodatabases, creating users and roles, applying permissions to data so other users can work with it. We will talk also about user management, how to deal with orphan connections. We will then transition to version maintenance workflows. We'll briefly talk about the new versioning model that we have available. We will not go into details as there is a dedicated session for that will go into branch versioning. We have a good set of demos to show you the practical use of our functionality. Python is the platform of choice since scripts can be built agnostic of the platform. So all the scripts we showed today can be run on both Windows or Linux, server or desktop with minimal changes. Within Python, you can take advantage of programming logic like looping or cursors. You can also integrate third-party functions within your script that Jill will show in her demo. It is also a great way to automate your workflows, which is why it is a preferred language among administrators. ArcGIS Pro now comes bundled with Jupyter notebooks that allows you to create and share documents that contains live Python code. We saw great demos at the plenary this year. Jill will be using both these powerful tools, Python and Jupyter, in her demos today. When we talk about the geodatabase, we really talk about two distinct sets of tables. First is the geodatabase system or repository tables, which is metadata in the geodatabase that stores information about the contents of your data. It also stores information that is maintained at the workspace level so that it can be applied to multiple data sets, for example, versions and domains. The administrative operations on the repository tables includes upgrading, managing connections to the geodatabase, managing versions. The second type of tables are the user-defined tables, and these are the tables that you are probably more familiar with. These are the tables, feature classes that actually store your data. These are the tables you see when you connect to a geodatabase from an ArcGIS client. You may have tabular data, feature classes, or other types of feature data sets. Administration operations on this data usually change the state or the structure of the data. Schema changes such as adding, renaming, or deleting fields, granting or revoking privileges, enabling additional geodatabase behavior on the data. In order to manage tables within a geodatabase, there are different types of administrators: the database administrator, the geodatabase administrator, and the data owner. In today's demos, Jill will be demonstrating workflows from each of these different roles. Let's take a few minutes first to identify each of these roles. The database administrator, this is the person responsible for installation of the database instance, user management, regular database backup, system security when users leave the company. This person is responsible for revoking the privileges from that instance. Performance monitoring is a very important aspect of their role in an organization, but the takeaway from this session, I hope, is that you realize that all the three administrators need to work together to maintain an efficient system. The Geodatabase Administrator is a user that owns all the system tables that I mentioned earlier. And because they own those system tables, this user has some unique roles and privileges in a geodatabase. They can edit any data that has been registered as versioned. They can view and reconcile any version, change any of the properties of a version owned by other users, and also perform compress in traditional versioning workflows. The data owner is the person who loads data into a geodatabase or creates new data. Modifying schema of data tables, or what was referred to earlier as user-defined tables. They are also responsible to enable geodatabase behavior like registering your data as versioned, enabling or disabling archiving, enabling editor tracking, or adding or removing fields. Let's talk about administrative workflows that are performed by a database administrator user. There are two ways to create an enterprise geodatabase. First is if you are starting from scratch and do not have a spatial database in your setup, then you can use the Create Enterprise Geodatabase tool to create a brand new geodatabase. Or you want to fully automate the creation of geodatabases for setting up testing environments. The DBA will be the person to create a new enterprise geodatabase, as you need additional privileges to create the underlying database before creating the system tables in it. The second way is maybe you have a database with spatial data, users, permissions applied. Now you want to take advantage of geodatabase functionality. You can use the Enable Geodatabase tool to lay down the system tables to convert your database into a geodatabase to take advantage of these behaviors. This tool will need to be run by the Geodatabase Administrator. Once you have your geodatabase created, you are probably going to want people to have access to it. In order to do that, you will need to create new users in your geodatabase. Most of the database administrators would be more comfortable creating users directly in the database. But if there is a scenario where you need to create users via the ArcGIS client, we have a tool for you. The Create Database User tool creates users with privileges to create data in the database. This differs from platform to platform, but is well documented, and if you are curious to find out specifically what privileges are needed, you can use this link to the help. The tool supports creation of both operating system authenticated users as well as database authenticated users. One thing this tool will not do is create the Geodatabase admin user, as this user requires greater privileges than what are provided by the tool. Going right along with creating users, you can also create database roles. This makes it easy to assign and revoke privileges to a number of users at a time. So rather than iterating through and assigning privileges to individual users, you can group those users into roles and apply privileges to many users at once. We would recommend creating roles first so that as you're creating new users, you can assign them to the correct role. We will see this in a demo. Again, this is done by the Database Administrator or DBA. Let's see a quick demo of the Database Administrator workflow through Python. Handing it to Jill now.
Hi, my name is Jill, and I'm going to be doing the demos in this session today. Before I get started, I want to mention the program that I have opened. So this program is called Wing, and it's a program that I like to debug my Python scripts. But this script could be run in any environment that you guys like for your own debugging. Another thing to note is that I'm using Python 3 for ArcGIS Pro in the demos today, but you could run these as well using Python 2, which comes with ArcMap. So in this script, we're going to create a new enterprise geodatabase. We're going to create users and roles. We'll create some schema, and then get it set up for multi-user editing. So the first thing that I've done is I've gotten the script running. We've imported our modules, and then we're going to set some global variables. So these variables that I have here are things that I'm going to be reusing throughout this script. So I have things like the platform. Our demos today are going to be done on SQL Server. I have my instance name, my my database name, and then I have some credentials that we're going to be using throughout the script as well. And I also have an authorization file that I'm going to be using to create my enterprise geodatabase. So the first thing we're going to do is create the enterprise geodatabase. I'm going to go ahead and get that started. We're using the create enterprise geodatabase tool, and I'm passing in some of those variables that we saw above. So the platform, my instance name, I'm giving the database a name, then I'm passing in some of the credentials that are required to create the enterprise geodatabase, and then my authorization file. So that should take a minute. All right, so our enterprise geodatabase has been created. Now that I've got my geodatabase created, I want to go ahead and create a connection to the geodatabase. So I'm going to do that using the create database connection GP tool. Again, I'm going to be passing in some of those same parameters from above. If you guys have ever interacted with an enterprise geodatabase in ArcGIS, you've used one of these connections before. So now that I've created a connection as the DBA user, I want to create some roles in the geodatabase. So I'm going to create a viewer's role and an editor's role. So to do that, I'm going to use the create role tool. I'm going to pass in my admin credentials, or my admin connection, sorry, and I'm going to create a viewer's role and editor's role. So that was quick. Next, we're going to create some users and assign them to those roles. So here I've created a Python dictionary of editors. So I have my editor users, where I have the username and the user password. And I also have a a dictionary of viewers. So what we're going to do is we're going to loop through each of those dictionaries. So for the username, password, in that dictionary, we're going to run the create database user tool. We're going to pass in our admin connection, so those credentials as a DBA user. We're creating database users, providing a username and password, and then assigning them to the appropriate role. So we'll get that started. As you can see, we've created a number of users and assigned them the roles. If you guys are needing to create operating system authenticated users, you can use this same method, but you wouldn't pass in the password in this case. You would just pass in an empty value. And then finally, I want to create the data owner. So this is going to be the GDB user. And I'm again going to use that same tool with my admin credentials, but this time I'm not going to assign a role to that user. So now we're finished our tasks as the DBA user. I'm going to pass you guys back to Annie for a little more content.
Thanks, Joe. That was a good roundup of how you can create your enterprise and also create users and roles all in one script. So moving along, let's talk about administrative workflows that are performed by the dataset admin user. So once you've created your enterprise geodatabase, you're going to start loading data into that geodatabase as the next step. We have numerous tools for creating data in your enterprise geodatabase. You're probably going to be familiar with these. Most of them start with the word create. As listed in the slide, we also have tools for loading data. When you use these loading tools, you will need to be connected as the data owner. Once the data is loaded, you need to manage privileges on your data to determine who can access it. You do this using the Change Privileges tool. This tool will take a list of data sets and allows you to grant or revoke either view or edit privileges. When you grant view, the user can select data, contents from that table, and when you give edit, the user can insert, update, or delete contents from that table. You must be connected as the data owner to perform these functions. Handing it back to Jill to walk us through some of the dataset admin workflows.
Okay, so we're back in our same script. We're just going to continue on after we got some of that information from Annie. So the first thing that we're going to do now that we're done our DBA tasks is that we're going to create a connection to the geodatabase as the data owner, so that GDB user that we created. Again, we're using create database connection tool, and we're passing in some of the variables that we had above. Now that I'm connected as that data owner, I want to go ahead and load data into the geodatabase. So I'm going to do this using import XML workspace document tool, and I'm passing in my owner connection. Get that running. I'm also providing an XML workspace document that I've already created and exported from another geodatabase. And in this example, I'm choosing to run schema only just to speed this up a little bit. You can import your data as well. It just takes a little bit longer. Once that data is loaded into the geodatabase, we'll want to build a list of the feature classes, tables, and feature datasets in the geodatabase so that we can pass them into our tools. So to do that, we're going to use arcpy's functions list tables, list feature classes, and list datasets. So that will gather a list of the datasets. As you can see, we've loaded a number of them. And the first thing we want to do is we want to grant the appropriate permissions on the data. So we're going to use the change privileges tool. We're going to pass in our data list, and we're choosing to give the viewer's role select privileges. And then we're also choosing, we're going to run the tool again, pass in that same data list, and this time we're going to give the editor's role editing privileges. So we have the select as well as editing privileges. So once our permissions are updated, we're going to register the data as versioned. So we're going to use that same data list, and we're going to loop through each data set, and we're going to use call register as version tool. And then we're just going to pass in the data set name. So that is registering all of our data as versioned. When that finishes, we're going to want to create a version for each of the users in the editor's role. So that editor's Python dictionary that we had above, we're just going to reuse that same dictionary. We're going to iterate through the dictionary. We're going to create a connection to the geodatabase as that user. Once we create that connection, we're going to create a version from the default version as that user, and they're going to be set to the private access. So as this is looping through, you notice I also have clear workspace cache tool in here. And the reason that we're doing that in this case is because we're creating a database connection and we're reusing that same file for each time we run the tool. And we just want to make sure that we don't have any caching happening. So this is a great tool to use for that. So as we're waiting for the last of our versions to be created, let's take a look in ArcGIS Pro and see what we did. So if I open up Pro, I've created a connection to my folder already. We can see the connection files that we created. If I were to connect as the data owner, I can see the data that was loaded into the geodatabase. Let's take a look at privileges. So we can see that the editors have full editing privileges, viewers have select only, and the SCE user has full editing privileges. And this is because the data is registered as versioned. And I'll give you back to Annie.
All right, thanks, Jill. Press that once again. Yeah. So now in the next set of slides, we will talk about versioning administrative workflows as the Geodatabase admin. Before we dive in, we are going to talk about why we might want to disconnect users. Maybe you have some users that are connected to your geodatabase and have gone home for the day. They have locks on your data and you want to make schema changes. Or maybe you're the DBA who needs to perform some maintenance on the server. We have multiple functions for managing user connections. First is the accept connections function. You provide an admin connection and a Boolean value as parameters. True means new connections to the enterprise geodatabase are allowed, and false means new connections are blocked. If the parameter is set to false, currently connected users will not be abruptly disconnected. They can continue to work in that session. When they start a new session or try to create a new connection or do an operation that requires a new connection, those will be blocked. The second function is the list users function. This function returns information that you can use to ask questions about who is connected to the geodatabase. Finally, the last function we have is the disconnect user function. This allows you to disconnect users from the geodatabase by passing in the ID that's returned from the list users function or by specifying the all keyword. In the setup where you have services being published, in our case, we are talking about services that are published by reference, feature services where data is not copied to the server, but instead references the data in the geodatabase through a connection file. Services connect as regular users. The geodatabase does not know that there's anything special about the connection. So if you disconnect everyone from the geodatabase, this would include any services that are making a connection. ArcGIS Server has logic that will attempt to reconnect stale connections. Because of this, you should block connections before disconnecting. So ideally, the steps are you block connections, stop the service, perform your admin tasks, allow connections, and then start your service. If you do not stop your service or block connections, you may see strange behavior, such as partial drawing, or you have errors logged in the server or failed queries. So these are just some symptoms people may report. While we are talking about connections, I would like to also bring to your attention the Update Enterprise Geodatabase License GP tool. This can be used to allow clients to continue working with the geodatabase without interruptions caused by an expired license. So if your organization licenses ArcGIS Server for a set time period, your geodatabase admin can run this tool with a new server authorization file to update the license information in the geodatabase before the existing license expires. You can also do it after, but just to not get people to that state where they have connection failure, this is a tool you can use to run prior to that expiration. Handing it now back to Jill to show us how to manage connections via Python.
Okay, so before I get started, I want to talk about what I have open here. So this is an ArcGIS notebook, which is built on top of Jupyter Notebooks. Jupyter Notebooks is an open source web application that allows you to create and share documents that contain both computer programming code and rich text elements. And this comes with your installation of ArcGIS Pro 2.5. If you guys were watching the plenary, you probably saw several demos using these notebooks. So in this demo, I'm going to show you guys some of the functions that Annie just mentioned, accept connections, list users, and disconnect user functions. So the first thing that I want to do is import arcpy, and then I'm going to set our GDB admin variable. So this is a connection to the geodatabase as the SDE user or the Geodatabase Administrator. So let's run that. Next, I want to block new connections to the geodatabase using accept connections, and we're going to set that value to false. So that means that no new connections can be made to the geodatabase. So let's see who's still connected to the geodatabase. I can do that using the list users function and passing in that geodatabase admin connection file. So as you can see, tons of information is returned here. You have some information about the connection type, what time the connection was made at, the username. A lot of information. So to clean this up a little bit, let's just look for the username and the user ID. So here are connected users. If I were to connect as a user now that accept connections are turned off, for example, I went to connect as Gary, I would get an error that the geodatabase is not accepting connections. So as I can see my connected list here, I happen to know that the Brent user is out of office. I spoke with him earlier today and he was finished up. He must have just left something open by accident. So I feel pretty safe about disconnecting Brent. One thing that I want to note is when you are disconnecting users, you do need to pass in their ID and not their name. And this connection ID changes for every new connection, so it won't be the same. It's something that changes as they create connections. So let's go ahead and disconnect Brent, whose session ID is 140. Now we can regenerate the list to see who is still connected. So we can see Brent is no longer connected to the Geodatabase. So next I want to use a list comprehension to disconnect all users except for the SD feature server users. So this might not be what you guys necessarily need to do. I just wanted to give an example of where I wanted to get majority of the users off of the Geodatabase to do something like a compress. I can get a more efficient compress with less users, but I did not want to disconnect any of my feature services. So this feature server user, I happen to know in my organization, is the user that points to my feature services. So we can filter those out of the list to disconnect. So we'll be disconnecting users 141 and 142, which is Colin and Craig. So we can disconnect those. Let's regenerate our list. And we'll see that those guys are disconnected. So now I would do my admin tasks. And when you're finished, you want to remember to run accept connections again and set that value back to true. Otherwise, you might see some weird behaviors or people won't be able to connect to your Geodatabase. That's it for the connection management demo. Back to Annie.
Right, thanks, Jill. Now let's switch gears and talk about versioning administrative workflows. We all are familiar with traditional versioning workflows with client-server versioning that we refer to as traditional versioning. The goal is to get edits from the Delta tables into the business tables. To do this, we have the reconcile, post, and compress operations in place that we have been running on, that has been well documented, and there are workflows in place to do that. With a new type of versioning called branch versioning, the traditional versioning workflows can be performed in a services-based environment. The bonus with branch versioning is that administration is much easier. The base table gets additional columns that are used to track edits. So with branch versioning, there is no requirement to compress to get edits to the underlying base table. The parts of the version administration workflow that we are going to focus on are the reconcile process, updating statistics and indexes with traditional versioning. So with reconcile and post, you do these operations to either get edits from the parent or post edits to the parent version in the Geodatabase. In Python, we use a reconcile versions tool. We do recommend that you run this as the Geodatabase Administrator in an automated maintenance routine, only because this user can see all the versions in the Geodatabase. It just makes it a little bit easier to write any scripts that need access to all versions in the Geodatabase. Compressing your Geodatabase, right? You can run the compress GP tool to trim the states in your Geodatabase and also clean up records from the Delta tables. This needs to be done as the Geodatabase Administrator. With branch versioning, since the edits are directly written to the base table, there is no need for compress. We've always recommended that you update statistics after your reconcile operations. But this also holds true for any major data change events. If you are appending a lot of data or performing a lot of edits, it's a good idea to update your statistics and indexes. This just helps to ensure that your Geodatabase is performing well. This can and should be done by a Geodatabase Administrator to update the statistics on system tables, especially after a reconcile or compress, and also done as the data owner on their own data as well. Now that being said, databases now have excellent inbuilt mechanism to detect if statistics and indexes are stale and do a rebuild. So it would be best to work with your DBA to determine if a rebuild of indexes and statistics on tables are required. Now back to Jill to show us how version management is done through Python.
Thanks, Annie. So in this next demo, I've written a standalone Python script that's going to deal with handling connection management tasks, including feature services. We'll go through reconcile, post, and compress. We'll look at rebuilding indexes and updating statistics, and then we're going to generate some email reports as well. So the first thing I've done is I've imported the required modules. As you can probably tell, this demo is a little different from our last two demos where we were only using arcpy. This time we're importing a bunch of different things, but these are all third-party modules that come built in with Python. So there's nothing extra that you need to do to get these. Next, I have several functions that I've written to do specific tasks, like sending emails, opening a URL, or dealing with our feature services. I'm not going to dig into these in this session since we don't have a lot of time, but you guys will have the code so you can take a look and play with these yourselves. So since we're dealing with feature services today, I am going to need some information about my server. So I have my server URL, and then I have some credentials for my server. We're going to set a variable for our Geodatabase admin connection. So it's a connection file I've already created. And next I've included a few Boolean variables to determine whether we want to run some of those administrative tasks, such as updating statistics and indexes or dealing with our replica versions. So these are in here for you guys to use. If you need to, you can set them to true or false. It's just an example to kind of show. Sometimes you might need to use these. Sometimes you might want to skip. So we'll dig into each of those. So the first thing that we're going to do is we're going to block any new connections to the Geodatabase. Next, we're going to generate a list of users that are still connected. So we're passing in our admin connection. And now what I would do is I would have a lookup table that would basically match any Geodatabase user to their email address. So we could look at all the connected users and then build a list of emails, and we would send out an email to each of the connected users, letting them know that maintenance is going to be performed in 15 minutes and to please finish up your work. So I'll show you what that would look like. Here are our connected users, and here's our email telling us to disconnect. Instead of waiting 15 minutes, we can go ahead and set that time to 0 and move on. Now we want to deal with our feature services. So I've written a function that's going to get a list of our feature services just from providing our server URL. Now that we have a list of feature services, we're going to loop through each of those, and we're going to call another function that I've written to stop each of those feature services. So all this is doing is it's sending a request to the server REST API, telling each of the services to stop. So you can see my print statements, we've stopped 3 services. So now I feel pretty comfortable about disconnecting all users since we've stopped our feature services and we've given everyone notice to get off the system. I'm going to go ahead and use disconnect user, and this time I'm going to pass in the all keyword. So now that everybody is off, let's go ahead and generate a list of versions that we will want to reconcile. So we're going to do that using arcpy DA list versions, and we're going to pass in our admin connection. The reason we're passing in our admin connection is because the admin user has permissions on all versions in the Geodatabase. We're also going to use list comprehension to filter the list of versions that we want to reconcile. In this case, we want to reconcile all versions where the parent version name is the default. So you guys can kind of play with this and create filters as you need from those version properties. Next, one of my Boolean variables is whether we want to include or exclude the replica versions from reconcile and post. If you guys have a workflow where you don't want to reconcile your checkout replicas, you can use this bit of script to do so. In this case, I do want to reconcile my replica versions, so we'll include those. But if we were to filter those out, we'd be using arcpy list replicas and passing in our admin connection and getting the version information and then removing it from that list to reconcile. So now that we have our list to reconcile, we can run the reconcile versions GP tool, and this is meant as a way that you can automate reconcile and posting your versions. So we're going to pass in our admin connection again because we have permissions on all versions in the Geodatabase. We're going to reconcile all versions. I'm going to pass in my version list. And then I have a few other parameters set here so that I know how I want to deal with my conflicts, if there were any. Let's go ahead and run that. We're also outputting a reconcile log so we can see all of the things that happened while this tool is running. So now that we've reconciled and posted, let's go ahead and run a compress on the Geodatabase, again as the admin user. Here's where we can decide if we want to update statistics and rebuild indexes on the system tables, so those SDE repository tables. In this case, we will do that. So we're going to run rebuild indexes. I'm going to pass in my admin connection, and then I'm going to choose the argument to run on the system tables. So this option for system can only be run as the Geodatabase Administrator. Next, we'll run analyze datasets with the same arguments. So now that we've finished our tasks as the SDE user, let's go ahead and allow users to connect to the Geodatabase again. Now that we've turned that back on, we can go ahead and start up our feature services. So again, this is using the same function as we used earlier to stop our services. We're going to loop through and start all of them. So as you can see down here, we've successfully started our services back up. So now let's connect as the data owner. So in this case, I've been given an SDE connection file. I don't know much about it, what user they're connected as. So one thing I wanted to point out is that you guys can use arcpy describe on a SDE connection file to get some of the properties of the connection file. So you might be familiar with arcpy describe for various other things. It's incredibly useful in Python scripts. In this case, we're going to look at the connection properties, and we're going to get the connected user name. So no surprise here, we're connected as the GDB user. Next, we want to compile a list of the data owned by the GDB user. So in this case, we're again using list tables and list feature classes, but this time we're passing in the username as a filter. And the reason that we're doing this is because with these admin type tasks that need to be run as the data owner, if I were to have permission on someone else's data in here and those tables were returned, I wouldn't be able to run those admin tasks if I'm not the owner of the data. So this is a way to filter that list. So now that we have our list of data sets that we own, we want to run rebuild indexes. So this time we're running the tool with our owner connection. We're not running it on the system tables. We're going to pass in the list of our data sets. As that runs, I guess you guys have noticed I have been building messages as we go, and we're going to use these as an email report when we get a little further along. Next, we're going to run analyze datasets, again with the owner connection and passing in our data list. So now we're finished the tasks as the data owner. And now we're going to email ourselves a report of the tasks that we just did. So we'll use that send email function to send an email. And I will show you what that email would look like. You can see the information about our services stopped and starting, and then our reconcile log, and whether everything else was successful or not. So this was really great that I could kind of sit here and go through this without having to click and kind of do a lot of manual work. But the great thing about using Python scripts is that you can truly automate Python if you use something like Windows Task Scheduler, or if you're on Linux, cron job. So if I open Windows Task Scheduler, I can create a basic task. I could do something like run reconcile. I'd want to run this weekly, say Monday, Wednesdays, and Fridays. If we are disconnecting users, it's a good time to do it when nobody's going to be on the system, so 3 in the morning. what we want to do is we want to start a program. And that program is just going to be the path to our Python executable. And then we also want to add an argument, and the argument is going to be the path to our Python script. Open the properties dialog and click finish. And that's because I also want to run whether the user is logged on or not. More than likely I won't be logged on at 3 in the morning, so it's a good idea to check this option. And then I also want to run with the highest privileges. So that would run 3 times a week for me now, which is great. I don't even have to be in the office to do these things. Before I wrap up and give you guys back to Annie for a summary, I do want to mention that some of these automation type tasks are available for branch versioning as well. So she briefly mentioned branch versioning, and there is another session that dives in a little bit deeper. I'm going to quickly kind of do a high-level overview of the types of things that you could do. Again, we're going to be working with our server, so I have some information for our server and our geodatabase. So you can do things like preparing the data. So when you prepare data for branch versioning, you would load it, you'd do things like adding global IDs, enable editor tracking. When the data is published, you can automate creating your versions. And then you can also automate reconcile and posting as well. So this script is also going to be included with the demos that we're sharing today, so feel free to dig in and reach out if you have any questions. And I'm going to send you back to Annie for a wrap-up.
Thanks, Jill. That is the big takeaway from this session, this demo that Jill has put together to show how you can, just through Python, manage your versioning workflows. So just to summarize, as you saw from our session today, I hope it's evident that the Geodatabase is open to Python developers. So if you're looking to administer your Geodatabase, there are lots of options for doing it through Python and geoprocessing. And as promised, this is the link to the slide and the code. Thank you for joining us online to see this session for 2020. Hopefully we will meet in person next year. Thank you.